yes, we are HD Rain. So if we can switch to the presentation, it's just a few slides. So I'm François. I'm one of the co-founders of HD Rain. So we founded the company 5 years ago, and I'm together today with Jordan Brajon, who is responsible for data science in HD Rain, and he will talk a little bit more precisely about what we do in data science in the second part, because he knows better than me this topic. So yes, basically HD Rain is a weather company. So we design, we build sensors. We put sensors on the ground, especially to measure rainfall, but also other parameters like temperature, air moisture, pressure. And then we combine the data coming from all the sensors we put on the ground in our algorithms to produce maps of different parameters, such as rainfall, and to produce forecasts, short-term forecasts, 1 or 2 hours in advance, especially for insurances, for cities, or for national weather services in other countries than France. So just a few illustrations. Our main technology at the beginning was about a new method for measuring rainfall. So what we do, actually, we don't measure directly rainfall, but we measure the loss of power that the raindrops produce over signals coming from television, TV satellites. So if you have a TV satellite, this satellite emits a signal that you receive to watch TV, but when it's raining over the link, the rain attenuates, fades the signals. So we lose power. A few years ago, when it was raining too much, you had no more TV on your screen because it was cutted, it was totally faded. So what we do is that we install dishes, classical parabolas on the ground, and we put sensors behind the dishes to measure the power coming from the satellite. And when it rains, we measure how much power we lose, and we're able to convert this loss of power into rainfall amount. So then we install many sensors in an area of interest. For instance, in the south of France, we have installed about 700 sensors, and we combine the data coming from the entire network to produce rain maps in real time and to produce forecasts. So this is a sensor in the south of France, near Hyères, in an island in the Mediterranean Sea. So you have the classical parabola. We receive the signal. The sensor is here to measure the signal. It's powered with a solar panel, and we transmit the data using a SIM card with 2G or 4G. And so then, when we have combined all the data coming from all the sensors, we're able to produce rain maps like this one. So this is an instance of our web app in last September. And so we can see where it's raining, more or less. And this is an example of the total amount of rainfall we have measured in south of France for a special day in September. So it was probably flooding here near Nîmes or near Montpellier. So that's it. And so when we started the company 5 years ago, there was almost no machine learning in our system. There was just a little bit of machine learning to treat the signals coming from the satellite. So this is an example of the raw data that we measure. So this is the amount of signal, the power coming from the satellite on the ground, depending on the time. So here you can see that it's definitely raining. We lose a lot of signal. It's clear that it's raining, but here it's not that clear. Maybe it's a cloud, maybe it's something else. And so we need machine learning from the beginning to identify in such a time series what is rain, what is not rain. So Jordan will talk more about this, but at the very beginning it was a very simple algorithm we used, but we knew at this time that we need more machine learning to do this and also to produce the maps. So it was 5 years ago. We were just 3 of us at the beginning from the academic world. I did my PhD, a part of my PhD before on this topic. And then we used the OVH services at the very beginning. It was just small VPS. Then we joined the startup program. So in the startup program, we were able to have many advices from OVH to build our infrastructure, our architecture, because when we do science, we are not operational, so we don't do operational algorithm in order to deliver with sufficient confidence system to clients. So they helped us with this. We tested many different architectures on the public cloud, and now we are about 14 people in the company. So we have specialists that are able to deal with these operational systems. So that's it. So I will let Jordan say more about the algorithms we use in machine learning now.
Hello to everyone. So I will go a bit deeper on the technology. So remember, we deploy many sensors in an area, and the goal is from the measurement of TV power to produce rainfall maps. So there are multiple steps to do that. At first, we work only each for station by station. What does it mean? It that we work only with one station at a time. So we have kind of power like that for one station. And the first step is to identify when it's raining and when it's not raining. So we have a time series as input, and for output we have another time series with 0 or 1. It's binary classification. So for example, with this kind of input, we can output something like 0, 0, 0, 0, maybe 1, it depends. 0, 0, 0, 0, and a lot of ones, a lot of ones. We just mean that it's raining, it's not raining. Then, after that, the goal is to predict the signal that we would receive if it was not raining. So, when it's not raining, it's easy. It's a signal that we actually measure. But the interesting thing to do is to predict that when it's raining. So during this period or this period. So we have 2 algorithms to do that. Maybe I can just explain a bit more the first model to identify when it's raining and when it's not. So it's time series as input and time series as output. So we use LSTM network to predict the binary classification, and the first layers are convolutional network. So we can talk about that a bit later if you want. So it's the first model. For the second model, there are two kind of models. So it's to predict the baseline, so the signal that we would receive if it was not raining. The first one, the easy one, it's just to plot a line, a straight line like that, to link the power just before the event and just after the event. So we have a kind of line like that, and we predict the signal that we think we would receive if it was not raining. So after that, we just need to subtract this prediction with the actual signal, and we have the power that we have lost, I don't know, because the rain. So the more the signal we lost, the more it's raining. So then, after this step, we have rainfall for each station. To do that, there are also another algorithm, because this one is not perfect. The main disadvantage is that we need to wait that the rain stop before to straight the line. So there is another algorithm. We work with LSTM and with another data, which is temperature, because this difference of the signal, you know, it's not raining, but it's still moving, so it's linked with the temperature. So when it decreases like that, it means maybe that the temperature increase. So when it's raining, we have developed a model who know how it will move during the rain, and we can predict the baseline. So after these 2 steps, we know how much it's raining for each station. And then we need to combine all the information to produce maps of rainfall. So these are these kind of maps we can produce. So imagine that we have some sensors like that. With each of them, we can measure how much it's raining, and the goal is to fill the holes. is to fill the holes. We know how much is raining here, we know how much is raining here, but we don't know what's happened here. So still we have two models. The one developed by Francois, which is running in real time, and another one I'm going to develop, which is not running right now. So we start with the Francois algorithm. So it's data assimilation. I don't know if some of you know how it works. We have a physics model who say that if it's raining, if the rain is like that, it will move like that. So it's a model who works with wind in atmosphere. So if the wind is like that, we say, okay, the rainfall will move on the same direction. And then the goal is to find the best map will fit with the observation. So for example, if we have a sensor here, we measure a lot of rain, and we know that the maps is going there. We'll put a huge amount of rain here. I think I'm not super clear for this part, so maybe if you have some question. But the goal is to find the best map will fit with the observation. So we can catch spatio-temporal relation in order to fill the holes. Maybe to give you a kind of example, if it's raining at 2 p.m. here, and if it's raining at 3 p.m. here, we can say, and we know that the wind is like that, we can say that it's raining the same amount of rain at, I don't know the hour, but at 2 p.m. and half here, because we have catch the temporal and spatio-temporal dependency with this measure and this measure. So we can average the two measures to say, okay, the rain has moved on this direction, and so at the middle of the time, between 2 p.m. and 3 p.m., the rain is here. So in the first algorithm, data assimilation, find the map will fit with the observation, and the other one is the one I'm going to develop. It's with machine learning also. So I will know. I won't explain in details, but if you want, ask me after. So I just give the measures of the station, and so it's my inputs, and for output, I want the algorithm to output the map of rainfall. So it's a part of interpolation. There is no forecast for now. I will explain later. So now we have just the measures from the stations, and we have a map of rain in real time. Then for forecast, maybe there is another slide, or no?
No, there is no other slide.
Okay. So we have won a project with CNES, and we are going to work with them and with another data scientist we have hired 1 month ago. So it's to develop forecast part of the company. So we work with our own data, the maps we have produced, and with another data, it's hybrid model with satellite maps. So we can see a bit farther than our maps, because we can't have sensors from the ocean. So we are not able to see the rain which is coming from the ground. So with satellite maps, we can forecast more easier the rain which is coming from the ocean. So the goal is to hybrid these two maps in order to forecast map in future, 20, 30, 1 hour ahead. And to develop these models, we have worked with OVH. I have developed this model on GPU server because it's a huge model and it needs a lot of time in our case to develop. I don't know if you have something to add, François.
François?
No, if you have questions, Fanny or the public.
If I have, do you have question in the public? Yes? I arrive, Bastien.
Do you check also competitors' forecast and you map them together to make something like a recap overall? Because you have simulations there, but also you have, let's say, satellite simulations and so on, and you compare together to give some result to customers?
Yeah, yes, we just start to do these comparisons. Actually, when we try to forecast rainfall over very short term, there are two really different approaches. On the one hand, you can use the models, like the models produced by Météo France. They do predictions 1 day, 2 days in advance, but it's not really efficient for very short-term forecasts because when there is a storm in the middle of the summer, for instance, they don't know if the storm will be at 3 p.m. or at 4 p.m. They don't know it will be in Lyon or in Saint-Étienne. And so it's better to do very short-term forecasts, not to use the models, but to use the reality measured on the ground at time t, and to extrapolate the evolution of this situation in the next 1 or 2 hours. So that's what we do. And so we try to compare to actors. We do the same thing. And generally, the difference is in the input data they use. So Météo France, for instance, they use their radars. We were able to produce the same kind of maps over France. We just tried to add a better resolution. But the idea is the same. They take the map at time t. They see how the rain cell moved during the last 2 hours, and they suppose that it will do the same in the next 2 hours. So we do the same, so we have the same results actually currently. And we really hope that machine learning will help us about this, because the idea is to capture the real evolution with fine scale and not just a large vector of displacements. And so there was a paper a few months ago by Google about this. So they are better than it's better than what we do and that Météo France do. It's clear, and so we will try to do the same actually.
Thank you. Another question? Yes.
What is the main advantage of using satellite dishes compared to regular rain gauges?
So different advantage. In France, there are radars and rain gauges. So we have 2 competitors in measurements, radars and rain gauges. Rain gauges, it needs a lot of maintenance because it's there are issues with the instrument. So it's mainly the maintenance and also the resolution. Rain gauges is very punctual. It measures the rainfall where it is exactly. We measure the rainfall average about over a path length, which is like 4 or 5 kilometers long. So we can have a more integrated measurements. If it's raining a lot here and less here, we will have an average. So for hydrology, for instance, it's better. Compared to radars, it's mainly cheaper, actually. Radars, there are many radars in France and in Western countries, but for instance, there is no radar in Ivory Coast, and so that's why we are also in Ivory Coast, because we have a sensor which is quite cheap, which is easy to install, which is robust because the map is produced by many sensors and not by one giant sensor which can have issues. So in foreign countries, definitely the price is the advantage. And in France, we are only around the Mediterranean Sea because our solution is very interesting when a huge precision is needed. So we can adapt the precision. We can put more sensors if needed to have a better precision. And it's important for flash floods, especially in the south of France.
Thank you. Last question.
How do your customer buy this? Is it a subscription to map through a web app and then they pay on user basis? Or is it API that with all your capabilities, forecasting and so on, and then they buy this? where are you for that?
Yes, both. Actually, we don't sell the sensors, so indeed we sell the data and the web app. Now the web app is fully operational, so we sell a subscription to the web app. And for the API, we are working on it, actually. So right now, we give them the maps on FTP servers, for instance, but we will have an API in a few months.
Okay, another question? I have just one. You tell me one time that when you don't have made a study about AI and you are not in the serials you begin with this story of this startup, how it works, how to enter in this area for you, how do you use that?
For you.
Yes, it's
I'm
for
not
me.
in the AI. I'm still not in the AI for my part.
So I have been hired at first, and I have not a lot of knowledge for that. But I start step by step. I mean, I've been hired 3 years ago, so just start step by step. Watch some videos, some formations, work on some articles with people who are doing almost the same thing than us,
And how you deploy that on the infrastructure and you make your test and learn? You are a startup, and I think a lot of startups who maybe want to try to go on AI, to put AI on their solution. They are not, they are beginners too, because. And how you implement that?
Okay, for me it was easy because I have really a lot of time. I think it was my internship at first, and I'm not sure it's the same for the other startups. So I really have time. There are just a small thing done with this solution. We won't deploy all the steps at first. So I start really step by step, and I first try to work on my own computer, on my own laptop. There are some errors, check what's wrong, try and test, and then it move more and more complex.
Okay.
But,
it's good to have internship.
Yes.
To try new things.
Yes, and just about AI in weather, I can say that many people don't really like AI in weather sciences because they are physicists and they are used to modelize, actually to solve the differential equations, the partial differential equations, and they prefer generally to understand the physics and to solve the differential equation. And it was the same for me at the beginning. And I'm definitely sure that AI is great for doing this, but I'm still not a specialist in AI because I like to do the physics. And so currently in many weather centers, they step by step, they start using AI to add AI in their numerical weather forecast systems in some parts, but it's not very developed until now because of this.
Maybe just to add something
sure.
about your question. So I started with some basics with two MOOC, two formation, and I have really the first basic to work with AI. By the way, if you're interested in the MOOC, I can tell you which ones. And then it's all the days it was looking some articles, looking for my needs, and working like that. So I have some needs, some question, reading some articles, which leads to over articles, to over topic, to over research, and then work on my way, and to search again and like that.